There we go. Let's. This section is totally denoted to the trapezoid, right? And so we'll begin by talking about the definition of trapezoid. It is a quadrilateral. So quadrilateral means it has how many sides, everybody?
Four.
Awesome. Has 4 sides with exactly 1 pair of parallel sides. Now that's the important part of the definition. Exactly 1 pair of parallel sides. So in my picture, this right here is the 1 pair of parallel sides. Notice that the other 2 sides are not parallel, right? If it was, it'd be a parallelogram. So this is our trapezoid. Now, for the parts of our trapezoid, we consider this a base, and we also consider this a base. So the bases don't necessarily need to be on the bottom. They could be, one can be on the top. So we call those 2 the bases, and we call the other 2 legs. So we have a leg here, and we have a leg here. So a trapezoid consists of 2 bases and 2 legs. So exactly 1 pair of our parallel sides. So why is this not a parallelogram? There's a reason. Yeah, what do you think, Isa?
Because it doesn't have 2 pairs?
Exactly, because it doesn't have 2 pairs of parallel sides. It only has 1 pair of parallel sides. That's what makes it a trapezoid. Yeah, Jay. Alright, so we can have regular trapezoids, which is what we had in the first box, which we'll deal with. And then we can also have isosceles trapezoids, in which case the trapezoid has 2 congruent legs. So these are the congruent legs. This leg over here and this leg over here. And they would be congruent, which makes this an isosceles trapezoid. And there's a theorem that comes along with the isosceles trapezoid, so I'm going to write that out for you over here. The theorem says, yeah, just like that. Base angles of the base angles of an isosceles trapezoid are congruent. So what does that mean? That means that this angle and this angle are the same. And it means that this angle and this angle are the same. That's what that means. Okay, so let's talk about the median then, the median of trapezoid. So if this is my base down here, all right, and this is my base up here, what do we call the 2 sides, everybody?
Leg.
My legs, okay? So this would be a leg over here, and this would be another leg on this side. Okay, if we find the midpoints of the legs, so find the midpoint of the leg, so probably right about there, and probably right about there. So we find the midpoint of a leg, meaning that this and this are the same, and this are the same. And we connect the midpoints with a segment, which I'm going to do right now for you. Right there. There, yeah, all kinds of good things happen. There we go. I was trying to do that as best I can. That's pretty darn close. Okay, so this piece right here, this is called your median. Okay? That is your median of the trapezoid. That's what the median is called right there. There it is. It's the segment that connects midpoints. And there are 2 theorems that come along with that. Theorem there and then theorem here. And we'll take care of both of them right now. So here are the 2 theorems that we're talking about. The median is parallel to the base. So we can go ahead and draw in that this now is parallel to the base, which is parallel to the base. That's what theorem 1 says. The other theorem says that the length of the median is the average of the bases, meaning that if I take the length of base number 1, which is this one here, and the length of base number 2, and add those together, divide by 2, I would get the length of that median in the middle there. Okay, here's an example for you. I have a trapezoid. Is this an isosceles trapezoid, everybody?
Yes.
How do you know? These are not, it's not isosceles. How do you know?
Oh, the sides are congruent.
Sides are congruent, okay?
Wait, I thought it's just 2 or more sides have to be congruent, right?
No side is congruent here.
Oh, it doesn't mark.
Yeah, they're not marked the same. Yeah.
They're not the same.
So this is a regular trapezoid, not isosceles. The question I have for you is, how do you know that that is the median? There's something in the picture that gives that away. What's the median?
It's a parallel line.
Yeah, no, well,
The 2 midpoints.
notice that, how do you know F is the midpoint of BC? Because they're each marked congruent. And then how do you know E is the midpoint of AD? For the same reason. So therefore, the segment that joins the midpoints has to be the median. Good. Now, how long is the median? That's the question now. Okay? No, not half.
19.
Okay? I have a 19. How do you get a 19 out of this?
You add them both together and divide it by 2.
Mm-hmm. So this is the median.
You take the average of both and divide it by 2.
So the median
That's what it says.
has to be the sum of 13 plus 25 divided by 2. So that means I'm going to have 38 divided by 2, which means I'm going to have 19. So this is a length of 19 units.
So would you say median equals 19?
Median is 19 units, yeah. Okay? All right, for this one, I want you to find the length of the base that is not labeled. So the bottom base is 32. You know the median is 24 because it is the midpoint of the two segments. It's the segment that joins the midpoint of the two legs. The question is, what is the length of the top base? Try to figure that on your own right now. So is this what you did?
Why is it 22?
Well, I didn't do that. I just did it.
24 has to be the base plus 32 divided by 2. All right. So this is the algebra of what you did, right? So because the sum of the two bases divided by 2 has to equal the median. If the median is 24, then I set 24 equal to base plus 32 over 2. So that means 48 is equal to the base plus 32. So subtract 32, subtract 32, and how much do we get?
16.
There we go. So this has to be 16 units.